Codurance? Great. Okay, so Seb just did a wonderful, very practical presentation. This is not going to be very practical. Is that okay? Okay, it'll be good. We can take your shoes off. We're close to the weekend. Okay, not really, but fair enough. Anyway, so one of the things I've kind of noticed about how my career has gone in a way is I feel sometimes out of sorts and sometimes in development communities, even though I'm a developer and have been for ages, because I have more of a science bent than an engineering bent in a way, right? In engineering, we're always looking to solve the problem, solve the problem, solve the problem, right? In science, it's kind of like, I want to understand how this thing works, right? And so what I've been kind of reflecting on quite a bit recently is that I think there are a lot of things that we can know about software development, how process and teams and architecture interact in various different ways. But we don't really talk about those dynamics all that often because we're quite often looking for the particular solution. So have you ever heard of the Spotify model? Yay, should we use that? A lot of these things are contextual, but then the question becomes, how do we basically understand the context that we happen to be working in so we can make decisions about what we're going to do in terms of team structure, process, and all these different things. So I want to kind of just introduce with this word here, isomorphism. Are you all kind of like aware of what this is? Very abstract. It basically means that two things can be put in correspondence one-to-one with each other. And if you look at this from the point of view of mathematics, it shows up quite often in graph theory, where you have two graphs and you're like, okay, are these two things isomorphic with each other? And if you can actually form a correspondence between the nodes and the edges, the nodes and the connections, you can say that one graph is an isomorphism of another. And there are lots of things that are kind of like this, things that tend to have roughly the same kind of structure in software development. And if we're aware of this thing, then we can kind of use it to our advantage. So a bit of a joke here, okay? This is a diagram of a graph, 1,700 nodes. Are each of these nodes microservices or teams? Anybody want to venture a guess? Well, not really both, but it's like, it could be either one though, couldn't it? I mean, wouldn't you expect microservice communication to be roughly kind of like this, and then also teams that coordinate work would be roughly the same kind of structure, right? So in mathematics, we call these random graphs, and essentially there's lots of dynamics around how random graphs form and when they develop hubs inside them and all these different things. So can I go a little bit further? I want to kind of carry this down into more of an everyday situation that we might deal with in software development first. I was working a while ago with an organization, and they had a bunch of different teams. And as they were going along doing their things, there came the mandate that we should do more automated acceptance testing, right? And so naturally, each team was kind of looking around at different tools that they could use for things and kind of discovered that no tools out in the world were really suitable for what they were going to do. So they each decided to go and actually create their own tool in order to go and do their automated acceptance testing. Now, this didn't go along for too long before people kind of realized it's like, wait a minute, this is kind of like tremendous duplication of effort. What can we do about this? And so what they did is they said, okay, well, we can instead go ahead and kind of take some of this code, take some of the best of it, kind of put it in the center, put it in a common repository, and everybody can kind of use it as a framework in a way. So have you ever lived through this kind of experience before? Yeah, it's the kind of thing which happens, and it doesn't have to be a testing framework. It can be various different things that kind of should be abstracted out in the context of our day-to-day work. Now, the thing which is really a tragedy about this is that it kind of fell apart, right? They took all this code, they kind of plopped it in the center, someplace where everybody has access to it. And then what was kind of funny is that essentially it wasn't really a staffed initiative in any sense. So you have this code here, and basically people make some changes to it, and they make more changes to it, and they make more changes to it. Nobody's living with it day to day. They just basically make changes on demand. Can you kind of imagine what the code looks like at the end of this process? There, right? And, it's kind of funny. When I, heard the scenario and stuff like this, I started looking at the code, and I looked at it and I realized that they had this one test base class, and everybody just threw their junk into this base class, right? Now, it's kind of funny because when you look at this from how does team and process interact with code, anybody who's had any experience in the industry is probably not surprised by seeing this sort of thing, right? And in fact, some people are really rather astute, could actually look at code like this and pretty much diagnose the situation that's going on with the teams, right? So it's kind of a funny thing that there is this interaction between code and process and team and architecture and all these things. And I don't really think we have very much language around how to go and solve these problems. But instead of going and saying at the beginning, hey, how do we solve this problem? Why don't we just sort of instead kind of talk about the dynamics of this? I guess everybody here knows what Conway's law is, pretty much? Know what Conway's law is? Raise your hand. Okay. Most people, great. Okay, so this is like a little pictorial representation of what Conway's law is in a very funny way, looking at different organizations and kind of like assuming how things must be broken down. The assumption here is that Amazon is very hierarchical, that essentially there's Bezos at the top, sends a directive, it goes all the way down. Google is terribly networked inside. People can just hop from one place to another and do things. Microsoft, I guess that's old school Microsoft where everybody is like in warring factions internally and stuff along those lines, right? I love the one for Apple here, where essentially you've got Steve Jobs in the center. This is, you can tell it's an old comic. And everybody's like, okay, what do we do? What do we do? What do we do, right? But there is this thing where basically how organization structure goes and influences various different dynamics within organizations, as well as, the code structure. So as I mentioned earlier, Conway's law, first articulated by Mel Conway back in the 1960s, believe it or not, made this observation that organizations that design systems end up producing designs that are copies of the communication structures of the organization. Now, one thing I'll basically mention with this is that it seems like this is one of those things where it's a very simple observation, but it's like really tremendous in import, okay? How team and process and code all intermingle in various different ways. And just to go and give you that little capsule for people who haven't encountered this before, the thing that he basically pointed out is the reason why code tends to go and mirror organization structures because there's extra cost to talk across teams. And if there's extra cost, chances are you're going to put an interface between those two teams in software to kind of like mirror the structure that you happen to have in the team. And this can quite often happen at a very unconscious level when you're going and architecting things or just working through things in teams. So team and code structure tend to be kind of isomorphic. And for people who are like aware of this, you've probably seen this in your work experience all the time. I want to march to another thing too, another place where dynamics of process and dynamics of team go and affect things. Have you all ever seen Pareto distributions before? Okay, power law, scale-free networks. Okay, so there's this typical thing that happens in most, in a lot of natural systems where you have like, say airports for instance. Heathrow is one of the most well-trafficked airports in the world, right? And so it has many, many connections to many different places. But there are some other airports that are a bit smaller, like I guess Stansted has fewer connections. But if you look at the overall graph of airports, you'll find that there's some there like Heathrow that have massive numbers of connections and some that have very few connections. And it kind of like trails down into a curve like this, right? So this also shows up in economics. It's kind of like the rich get richer. It shows up in various different aspects of systems that are interlinked and dynamic, Pareto distributions. I was kind of surprised earlier this year in April to go and see a paper that came up that was quite triggering about this sort of thing. But before getting to that, I want to go and mention this thing too. Power law distributions tend to basically occur in code as well. Okay, there's this paper from the past that basically goes and describes how if you look at, say, method size tends to go and you will have some very, very, very large methods and lots of very small methods. So there's that kind of a dynamic with things also. So maybe we're kind of like notice that in code bases. A lot of times we walk into a bad code base and we kind of assume it's like they're all 100-liners. But if you drew the distribution, you kind of discover that that essentially it is like one of these power law distributions. Have you ever kind of worked in this scenario where people say we're going to go and have a maximum complexity number for methods in our code base? You ever had that kind of thing? I tend to not recommend that because in essence it's kind of like if the natural distribution for these things is like a power law distribution, to go and actually put a hard limit on things is almost like doing this. It's almost like introducing distortion. This is a picture of what distortion looks like when you look at waves on an oscilloscope, okay? Distorted sounds basically have the top and the bottom clipped off. There's an arbitrary limit there, and you can very well distort a code base by going and saying we're going to have certain hard limits on, say, complexity, for instance. And I've actually seen scenarios where people do crazy refactorings to keep complexity or line count down to a certain level for individual pieces like classes and methods. And then when they do that, it's kind of like, oh, why don't the names make sense? Well, it's because we clipped everything at 15 or 20 lines and it just looks kind of ridiculous. So if you're lucky if you haven't encountered that. But getting back to the Pareto distribution thing, the power law distribution thing, this is the paper that I was talking about. Okay, there's this paper that came out in April And it's this one here. And it's basically doing an analysis of Git repositories. And I think they looked at over 1,000 of them. And they basically found that contribution to open source projects follows a Pareto distribution. That like 80% of the contribution comes from 20% of the developers signed up to go and work on it. Okay? So this 80-20 rule is like a characteristic of a lot of Pareto distributions. Anybody surprised by this at all? Yeah, I mean, if you're kind of aware of this kind of distribution and how it shows up, then you might not be quite so surprised by it. But you know, it's a funny thing with this paper because they basically chose this nomenclature to basically say these are hero projects because you have people that are doing like all the work and all these other things. Not very great use of language, but it does kind of point to this particular dynamic that occurs. And so these 20% of developers that kind of do 80% of the contribution on open source projects, it's not just the commits, it's also basically the conversation that happens online through GitHub and stuff like that. So if this tends to be true, what do we do about it? They actually went a little bit further. They actually looked at things and they kind of recognized, they found that basically the highest quality contributions in terms of not having many bugs came from those 20% of developers also. So what does this mean for us? I think it kind of like reinforces an intuition that we've often had in the industry, which is that smaller teams are better, right? If you have smaller teams, then maybe you can have very focused development, and as you keep on adding people, you keep getting into this place where it kind of just like kind of spreads out in a way and you have less quality as you're going through with things. So it kind of confirms intuition in a sense, and I think that's kind of fascinating. And I think if you look at the dynamics of this, it's like, why would the higher quality contributions come from the people that are doing the most in the code day to day? And it's like, well, they probably have way more awareness because they are there every day. They basically are really up on the dynamics of what's going on within the system, and they make better choices as they make changes. So I think there is this thing where basically we have cognitive limits, okay, that kind of constrain structure also. And this is why I think we kind of evolved like the two-pizza team thing that Amazon has. All these different things that kind of like indicate that we should keep teams relatively small. It's kind of sad that we try to go and exceed those bounds all the time, but kind of funny. I want to segue over to something else now, which is a little bit odd and different. Anybody ever hear of Galileo's scaling law? Okay, it's only a couple years ago I heard about this one. I'm like, how did I live this long and not hear about this thing, right? So it turns out that Galileo, who was a terribly smart guy towards the end of his life, put off in prison for basically irritating the church and such like that, and he's thinking as one does, right? And he basically recognized that there's this really interesting thing that happens in structure in the world, that there are limitations to any structure that grows in the world. Size basically has certain limitations. And he kind of like, sort of had the intuition about this, that if you take anything, you take an elephant, for instance, and you take like skyscrapers, it's like as things grow, the volume grows way faster than the surface area. And this is called like the square cube law, that essentially as things grow, you can't keep the same structure. It's got to change because at a certain point, as the volume grows, that structure is not going to be sufficient for that much volume because of gravity and all sorts of other forces. So it's one of those reasons why if you've ever seen like an old science fiction movie and they have like an ant, which is like 50 feet tall, biologists will tell you that's simply not possible. That structure cannot support, that kind of, organism at that scale, right? The reason I bring this up is because it does seem to be the case that a lot of things have this dynamic to them, that as you grow, it causes structure to change. Give you another example. If you know graph theory at all, you probably run into the notion of like cliques, right? Essentially, as something grows, you have these subgraphs that tend to be more highly connected than other portions of the graph, right? We'll see this in social situations quite often, right? That as things grow, you have a team, and then you'll have like, in a team of 20 people, there's always going to be like one or two people who basically are more, they work with each other more often than other people that form like a bit of a clique, right? So that happens in graph theory. It's basically recognized in social science. But this thing of basically internal differentiation happening as things grow is something which happens in code as well, right? Look at this class here called member. How many responsibilities does it have? Get to single responsibility. Well, I'm not going to ask you to tease them completely out because I can kind of like sort of show you that there's certain things that feel like they're more related to each other than other things. And it just doesn't seem to be the case that as a piece of code grows, the chances of a thing having only a single responsibility diminishes rapidly, okay? Growth causes differentiation in turn inside the structure. This sort of thing happens in biology also, right? Cells can only reach a certain limit of growth. They start subdividing into other little cells. And I think that this is an interesting thing. This is a form that kind of happens across many different systems, regardless of whether they happen to be physical, biological, technical, or social. And I kind of, thought it'd be kind of cool to give this thing a name, so I kind of call it ODON. I won't get into where the names come from right now, but this is the kind of thing I'm trying to go and get across here, is that there's this way of looking at structure, which is really domain and discipline independent. We can look at how certain things change over time and sort of make some decisions based upon those things. So there is this thing. As things grow, we have the tendency to want to go and break them into smaller pieces. Human attention is kind of fixed. The size of teams tends to be, you can grow a team out, but then it's kind of like it gets really, really unwieldy in terms of all the communication interlinks and stuff like that. So what do? As you have a bigger product, you break into smaller teams. And of course, as we do that, we break into smaller teams, then we basically have all this complexity of interaction between the people. And this is very much like what Fred Brooks talked about in Mythical Man Month, that late projects become later as you add people, but it's just like, I think as things grow in general, the number of communication paths makes things difficult. Component teams and feature teams. Anybody aware with this terminology? You've kind of run into these as well, right? And it's kind of funny to go and see the same thing kind of happening now in like the Spotify model. I talk to people quite often, and they're kind of like, we have this thing, it's kind of like we have these roving feature teams that can kind of go and touch any particular area of the code. And I remember the first time I ever saw this, way before the Spotify model, people advocating feature teams. And I'm like, oh no, don't you know what's going to happen? And they're like, what? And I said, well, it'll turn into this tragedy of the commons situation where you've got people making changes that aren't really versed on that particular area of the code. And because of that, you're going to get into a situation where the code quality might go and deteriorate. So have you ever seen that happen at all? Yeah, it happens occasionally. And then people introduce like component guardians and stuff like this to go and sort of, try to mitigate that thing. But I think that the choice of having component teams and feature teams is like really one of those things where it's kind of like, it's not like one is better than the other all the time, but they have different trade-offs. And the way that we see the trade-offs is by kind of looking at the dynamics. It's kind of like there is this force in a way which kind of makes it nice to go and have like a small team that has attention on this one particular thing for a long period of time, develops deep knowledge and can basically do things rather quickly. And that's kind of like that thing we were missing in that testing framework example. There was a piece of code that we just threw into a bin, and we modify it when we need to, but we've got no team tending it, right? So there's a power to doing that sort of thing, but there's a downside to doing that, which is kind of like if you're working on that team, things can become kind of stale because you have the same personnel, you have the same, you're touching the same code every day, you're not getting new ideas from outside and stuff like that. So, if you're aware of the dynamics of these two things, you can shuffle things around periodically and say, okay, this area of the system, feature teams. This other area, kind of critical, let's keep component teams. Let's rotate people around. Let's do different things. But that's really about understanding the dynamics of how people interact with code and what the run-on effects might be of going and actually having, durable personnel in situations. So to kind of like sum up where we are with this, we've kind of have a couple of different forces in play in software development. There's usually a lot of work for us to do. Code grows over time. Seems like effectiveness of groups of people tends to decrease over time, or at least as you have more and more people, you have more and more communication overhead in order to go and actually do the work that you need to do. We know that having silos tends to be a rather bad thing. Teams can grow stale. Unattended code grows stale. And each individual person, each individual team can only handle so many things. So this is almost like the design space of a socio-technical system, right? We want to go and have teams, organized around particular work. We want to have architecture that basically deals with these things. But, when you kind of understand what these dynamics are, then you can kind of like get in this place where you start saying, well, how do we play with this? How do we go and create our own bespoke structure in order to go and deal with the different things we might have to go and deal with in our context? So yes, there's that. I want to kind of like explore a little bit also this thing of like what's it like if we try to scale things down and basically sort of assume that we can do a little bit less work in a way? Here's an interesting dynamic, okay? When you're doing software development, you have a team, you have the tools you're using, you have the code that you produce. It seems like that we get into trouble as any of these 3 things goes and gets large. You have a 4-person team. What happens if you throw 10 more people in there? Does it go faster? Not quite so likely, okay? Maybe you're using like 5 or 6 tools. If I add 10 more tools for you guys to use on that particular project, is that gonna make things go faster? You have 10 more tools to learn and use, and you've got more interactions between those tools that are possible. Same thing with code. Is it easier to work in a code base that has, 50,000 lines or 50 million, right? Yeah, so we have certain limitations around these things. I almost feel that if we're aware of this sort of thing, we ought to be looking at, what's the size of the code that we're working on? What's the number of tools that we have? What's the team size? And that if we apply some factor to all these different things, there should be some limit past which we really don't want to go and grow particular things in order to really have optimal development. Now, having said this, we have this situation where we are typically trying to do very, very big things that will basically exceed a team of 3 or 4 people working together in close concert to go and solve things. So we have to go and actually figure out what we're going to do to deal with all those issues. But we should be aware of these particular constraints as we're organizing ourselves to do our work. One might say that the ideal situation is just like the cyborg, that essentially is like we have one person-machine hybrid that can basically do all the work and doesn't have to communicate with anybody else, because we know communication is lossy and there's all these other things, but we'll never have that kind of thing. At a more achievable level, I've talked to a number of people that basically do this. They basically have inside of companies, they're usually making things that are used by the company itself rather than facing out in a market. They have like 2 developer teams. And these 2 people come in every morning, they pair together. There's a little bit of redundancy there, so if somebody goes on vacation, work doesn't have to stop completely. Because they are both involved in all the decision making, they have deep and intimate knowledge of what it is that they're doing, and they just basically trade things off as they do things. They avoid communication overhead by basically going and having a constraint on their work. And quite often the process that they use is just ridiculously simple. It's like you have whoever your customer is in the same room, you chat with them whenever you want to, you do this work, maybe you don't even really do any planning. You just decide every morning based upon what they need, what you need to go and do. And I realize that this is an extremely ideal circumstance. This is not the typical thing that you might encounter when you're going and doing your work in a big organization, but it's kind of cool to go and recognize that it can be like an ideal sweet spot, and it's really something you can kind of like shoot for. Without naming the company, one of the big companies in tech now, I was going out to dinner with some people that were working there and kind of throwing out this idea, and they said, oh yeah, we do that. And it's like, there was one manager there, and basically he had like about 5 or 6 teams underneath him that were all pairs of developers. And each pair was responsible for a different project entirely. And they just worked in concert close in every day, and were able to avoid a lot of process because of the efficiencies they got by going and scaling things down quite a bit. Now, is it always practicable? No. And then we end up with things that are kind of like this, which is really like very matrix development. And all these things work, okay, to be able to go and actually set things up within an organization so that we can kind of like maximize knowledge transfer and do the things we need to do in order to go and keep the organization healthy, as well as keep the architecture healthy and stuff like this. I guess the thing I really want to point out, though, is that things like the Spotify model, they happened across this. They iterated, they did some cool things. But that ability is really something that we can all do too. We can basically design structure in organizations to basically deal with our architecture, to deal with the dynamics of the process, as long as we understand what these different forces are around the teams that are working. I want to go and mention this guy here, because it's kind of been influential in where I'm going with this. Anybody know of this guy, Bruno Latour? It's like a French sociologist of science. I was kind of first introduced to his work by a guy named Brian Merrick. And the very interesting thing about him is that he has this way of like modeling systems where you don't care whether the thing that you're modeling is a person, group of people, or an object. So if we were to go and actually like model our social interaction here, it would be Michael on stage communicating with the laptop, communicating with you, and you're sitting on chairs. And we put these all as nodes in a graph, and we talk about how they interact with each other. And he'll even play games like saying, like, let's assume that the laptop has agency in a way. It's like it basically pushes back on me in the same way that I push back on it. So if my clicker fails, that's an interaction we have to kind of be aware of. And he outlines a lot of this in this book called Reassembling the Social. But the key thing to come out of it was essentially something called actor network theory, which is all about going and say, taking the people and taking the objects and just kind of like just creating graphs to diagram how they interact with each other. I'm not saying that, hey, you should do this back on your teams and stuff, but the thing is, this view of like what the dynamics are, the forces between teams and code and the tools that you use and stuff like that, are things that we tend to be kind of aware of, but we can be diagrammatic about them also and help us as we want to reason through these things as we move forward with stuff. I kind of mentioned this a little bit earlier. Fred Brooks, The Mythical Man Month, he talked very much about what happens when you add people to a late project. But I'd say as well, adding nodes to a project makes it slower too. And when I say nodes, in a graph theory sense, I'm not talking just about people. I'm talking about adding more tooling, right? Adding more code to the project. All these things can kind of go and cause a project to slow down over time. There's a complex space between the interactions of tools, people, and code that basically introduces its own complexity, and if we're not really thinking about that, we'll be kind of like thrown quite a bit by what we see. So let's get back to our example. Okay, we had our testing app in the center. It wasn't really being maintained very well. It ended up with this cruddy architecture of a base class. Everybody goes in subclasses and adds things into the base class because nobody has really architected it properly. I showed you what that code looks like in there. So, what's the solution to this? Anybody have a solution? I mean, it's funny about this, right? We have a bunch of different teams. They have some code thrown in the center with no team associated with it. It's intermittently updated. It's funny with this. We can look and we can say, well, there's a couple of different possibilities. One is we can actually have dedicated people go and work on that, make a separate team that's going to be all about going and maintaining that testing framework, right? It might not be one of those things that would be really called for because, maybe the work that happens there is really intermittent. The other thing we could do is say, okay, well, why don't we introduce we can introduce like plug-in architecture around this stuff rather than doing the base class thing. That might be a decent thing to go and do. So we can solve the same problem at like the structural level in the code or like by going in and grouping people in a particular way to go and do certain things. The thing I want to kind of point out is that there is this tension between things that are in dependency relationships with each other. And I kind of call that neek. I've got this funny name for these things. But when you have that tension, it can resolve in many different ways. And this is true not just of software technical systems, but also physical systems as well. So like I said, there's many solutions in this network. You can essentially say, create a separate team, have explicit interfaces, like we have a plugin architecture for these things. Another one I didn't really mention is this thing here, incorporation. And what incorporation is kind of like going and saying, okay, well, sure, we're throwing all that stuff here in the center as a testing framework, but maybe we can just go and move back and actually just take that code and incorporate it into each one of these projects. So everybody has their own fork of this stuff, and they don't have to coordinate across the teams. And that can work also, right? So which one's the best solution? It depends. There you go, right? But here's the thing. Total consulting speak, right? It depends. But what I want to see is I want to see more people to be able to see what the dynamics of these things are, see what the patterns of the dynamics of these things are so that essentially you can gather more information about the context to go and actually make the decisions to do these particular things. In this particular case, with the organization I was working with, what they ended up doing was essentially going in and sort of like, okay, for the teams basically ended up going and using the framework in the center. They basically had dedicated people to review the pull requests. And they started moving towards the plugin framework. They didn't have it right away. But two of the teams decided to take the code and reincorporate it back into their team. So they essentially had duplicate code in there, but they felt that their use case was different enough to merit the duplication, and they just did that sort of thing. So this is all very structural, right? Very structural in the way of going and seeing the forces work together. And I think at a deeper level, one of the things that we should probably get used to doing is basically going and seeing, humans and code as being part of a system altogether, right? And it's kind of like when this synergy gets kind of like violated in a way, that's when things kind of fall apart. The code that you don't pay much attention to, there's knowledge loss, right? The people that worked on it eventually go away, and then suddenly you walk in and you're kind of like, what the hell is this? Trying to figure out what to go and do with it. So it's kind of like there's this thriving environment that can kind of happen, so that you take the code and you get rid of the team, and then you've got way less than if you had a team that was dedicated to it, right? We don't have a name for this, this particular thing, and that's kind of a shame. Kind of like a code team system. I think the closest thing we have right now is that Jessica Kerr in the industry, who's basically borrowed the term from Nora Bateson of semanticy, which is essentially like a living system that basically is complex and has interesting characteristics. Doesn't matter what we call it. I think we have to think in those terms, and that was like the fundamental tension that we were dealing with in the context of this scenario with this testing framework. So yeah, that's kind of where I'm ending up with this sort of thing. I think it's funny because when I kind of opened up this talk, I was saying, hey, I feel more like a scientist than an engineer in the sense because I just want to understand things, understand how things tie together. And then when you have that understanding, then you have more possibilities for going in and drawing solutions. There's something I'm working on off to the side, which is really kind of like, I'm calling it a book of form. And it's really kind of like this thing where you're going and taking, I've found a bunch of different things that I call forms, which are really things that tend to be structural and behavioral that exist across many different disciplines, or even in the physical world as well. And it's kind of cool because when you see one in one realm, then you're kind of like, oh, cool, I can basically sort of, if I can see that form in software, I can basically use the same strategies I would use with that one over here. And it's kind of an interesting thing. I encourage you all, on my Twitter feed, I basically post about this sort of thing a little bit also, which is kind of fun. But yeah, I really want to kind of like get across that this type of structural reasoning about the systems that we produce, where we basically see the humans and the code that we produce and the tools as co-actors, right, in a very socio-technical way. This is a vision of what we do, which lends us a lot of power. And it basically goes and gives us the ability to go and sort of like see novel solutions in the space. And it isn't then going in and saying, okay, we're going to use feature teams because somebody said feature teams is good, right? No, once you understand these dynamics, you're kind of like saying, okay, well, here's the thing I want to do, here are the trade-offs. I can see structurally what's going on with this sort of thing, and make choices based upon that. So that's where I wanted to kind of leave it. And if y'all have any questions or comments, by all means. Thank you very much.
Thanks for your presentation. It was quite interesting to hear that you're interested in cross-domain topics, how we can combine knowledge from different areas.
Yeah.
And I would like to ask whether you have played Go game.
Sorry, again?
A Go game. Go, yeah.
Go, no, I haven't. I've only read about how difficult it is for artificial intelligence, and I read enough to basically know I'd probably be very bad at it. So.
It's the reason why I'm asking, because it goes really deep into how individuals and groups interact and affects each other. Mm-hmm. And you can have kind of insight into the dynamics of different forces at action, on the board. And it's quite close to what you presented in here. Interesting.
If you have a book recommendation or something I should go to, by all means, let me know.
Okay, sure.
Great to catch up with you afterwards. I think if there's one thing that could be a criticism of some of this is that it's kind of like taking a very mechanical way of looking at things and assuming there's forces between the different actors and stuff along those lines. But we can use whatever mental tools we need to go and try to go and make some decisions. But I'll look into that, and I look forward to talking to you afterwards. Maybe I'll find out.
Well, I'm running to an airport right now, but I will find a channel
sure.
to communicate.
Feathers on Twitter. Just send me a DM. DMs are open.
Okay. Sure.
Thank you very much.
Bye.
Okay. Thank you very much, Michael.
Thank you very much. Okay.